Hello everyone and welcome back to a new video in modeling, analysis and design of our reinforced concrete building. And in today's video we are going to continue our modeling efforts with regard to this structure, and during this video we are going to try to put some beams here and put some slabs here and see where we are going to reach with the modeling of today's slab. With that being said, well, sit back, relax and enjoy the show. Okay, so one of our subscribers was asking me why did I reduce the moment of inertia of columns but haven't reduced the moment of inertia of basement walls. And to explain this, I need to explain to you the ASI code. Now, I'm trying to keep this code neutral, but this reduction must be done during the modeling, so I have to, at least for the ASI code, reduce the moment of inertia. So the first question was, why not basement walls? And I want to remind you, maybe I missed saying this in the last video, or maybe I sped up over it. I want to remind myself and you that I'm still thinking about whether to handle a basement wall as a beam or as a column, because each of those has a different reduction of moment of inertia based on the code. And the code doesn't even differentiate. The code calls them beam and column, and there is no limit, like when do I call a beam beam, when do I call a column column. Now you would say, well, obviously columns are columns and beams are horizontal elements. That's not true. Now this is going to be code specific, so allow me to show you something from the ASI code. In the ASI code, section 10.035 talks about the ductility requirements for beams, and it asks you to make sure that all tensile reinforcement would yield, and he wants you to achieve a strain in steel of at least 0.004. And this is ASI code, but there is like this factor of safety issue where if your strain is more than 0.005, your phi, factor of safety, is 0.9. If it's 0.004, then your factor of safety is different because it changes. The code tells you this is specifically applicable for elements that have an axial compression less than this. So this is the reason why in columns you don't have this issue. You basically multiply by 0.65, which is the lower limit of the strain. And now this seems to be odd, but I'm mentioning this because it seems there is a clear distinguishing between when to treat the check as a beam in comparison to when to treat the check as a column. Now, I am using this equation in my mind, this is what I usually use, to try to determine and try to differentiate between what a beam is and what a column is. Now, of course, those columns are going to obviously be axially dominated, but I'm thinking about the basement walls here. Should I apply 0.35 to them or should I apply 0.7 to them? And the reason why I'm not sure is because I don't know how severe the earth pressure is going to be on the basement wall in comparison to the axial load being carried by the basement wall. So I am kind of undecided yet. I have to perform the analysis and I have to remind myself to check the axial load. And if the axial load seems to be high, then I would have to flip this into a column. Reduce 0.7. And if it's not, I would not reduce anything. This is an approach I usually did in modeling. Of course, this is code specific, and feel free to tell me in the comments your thoughts about that. I am a little bit, to be honest, I am a little bit undecided, but I'm trying to keep it real and not just, speak assertively and in such a way that makes you believe. No, if I am undecided, I tell you, hey, I'm undecided on this issue, and I tell you the reasons why I'm undecided. Anyway, I will use thickness 200 here. I think this has a reduced moment of inertia. No? Okay, I will reduce it to 0.7. There we go, 0.7. And I'll basically modify this. So it's modified now. And for now, just for now, as a thing, I will just take this and apply everything to it. Just for now. We will talk about the differences later, but for now, I just applied this thickness. Another question was about whether I should use the cracked section inertia or the full section inertia when it comes to the calculation of deflections. My opinion here is, and that's an opinion, please notice, my opinion here is that you should use the cracked section inertia when you want to check out deflections using the service loads. You would think, okay, that's odd. The ASI code intends for those reduction factors to mimic the loss of inertia due to section cracking, and this happens during the ultimate load. Well, here I disagree. Believe it or not, the reduction of inertia and the section cracking happens even at the service load level if and this is 90% true, if the moments due to working loads exceed the cracking moments of the concrete section. Now you should check out your design books to understand this. The cracking moment of a concrete section is basically the maximum moment you can apply on a section before the concrete cracks, which is very limited, to be honest. So I am a fan of using the reduction everywhere. And now I'm at the basement. Now it obviously seems that the columns were planted here, and the distance here is 4.9 meters, and the distance between this and this. I'm just thinking now loudly how I would basically slab that, because the span is what would control the slab. So the spacing seems to be 4 meter 60, 4 meter 90 or something. Let me check if I can move any columns. So if I check here, no, I don't think I can move anything. Those are very well placed. Okay, how would I try to alleviate the stress on the slab? If I do a one-way slab, which seems to be the simplest, I would just span my beams going all the way from here to here and span the slab on this direction, which could be a good way. I will start modeling first. I will model here the option of having a one-way slab first. So I'll go to reinforced concrete beam. I want to make me a placeholder beam section, so let me just check very quickly what the column section was, because I usually like to have my reinforced concrete beam width be equal or less than the width of the column, which is 300. So I think I have one, and I think this has been reduced, and this has been reduced, but beam has not been reduced, right? So let me reduce this very quickly to 0.35. I'll add that or modify it basically and close, and now I will use BR for my beams. So I click here on the beam. Now, of course, this is a placeholder beam. Those will be changed during the design phase. Now, in the previous video, I told you that there is a little problem here during modeling, is that the column and the wall don't see each other. Allow me to show you. If I run the analysis, which will cause me all kinds of instability, of course. So those errors, I'm totally fine with them, to be honest, because it's just a dry run. I hit the escape button here. You see, look, the wall doesn't see the column because there is no discretization at the level of, is there? No, there's no discretization at the level of the column. So here, the wall doesn't have a discretization near the column because the column is not touching the wall. I stated before that there are two possibilities to deal with the column and the wall. Possibility one is that the column becomes an integral part of the wall, and possibility two is that you separate the column from the wall. As for now, I would choose to have the column be an integral part of the wall. So I have to move those columns. See, it's not really that easy to model things. And by the way, if I just want to give a quick apology while I'm working here, just in case if somebody thought that I was mocking last video, I didn't mean that. To be honest, I am actually more fond of junior engineers, as like I was a junior engineer myself in the past, and yeah, so my intention was not to mock, but was to actually appreciate. Now, a quick thing I want to get off my mind is a trick I thought about during this week, which was to counteract the problem of snapping in the basement floor. So the trick I had in mind is to just go up one level and then move it down. That's all there is. So I'm going to show you how quickly you can model using this little trick. So if I go to Slab again and select, I think it was a thickness 200 and the shell, not horizontal, it's actually much easier because the snap is now working. So basically rectangle, it's much faster. 1, 2, and 3. That's it. It's much faster and much easier. So the nightmare I had to endure last video seemed that it was just due to me choosing the worst possible way of drawing walls to overcome the problem with snap. Okay, so I'll just quickly show you how fast you can do this. I will basically video edit this. So, but look, it's really cool and really flexible and enjoyable, to be honest. Much better than what I had to do last time. Yeah, so this was much better than expected. It's much faster to do it like this. There is a shoe one missing. It seems I deleted it. I can draw it again, no problem. So that's one thing. The second thing is that I wanted to talk about is the positioning of those columns. Now those columns here are out of the basement wall, but you might think that you want to put them in the basement wall so that they mesh and see each other. Because if the column doesn't touch the basement wall, they don't see each other at all. So a good way of doing this is just to move. So I just take this and take this both, because they are on the same line, and we'll basically say edit, move or copy, and I will move it from here to the perpendicular. That's the one. So I move those two things. I want to give supports, because last time it was a nightmare to make those supports. So edit, support, I want them pinned, so now I can easily select all those edges, the ones that caused me a nightmare last time. It seems it's much easier than I thought. And here, okay, I have my supports here. And all I have to do is to basically take those things and draw them down 7 meters. So I just take those things, edit, move or copy, and I move it -7 in Z. So 0, 0, -7. Execute, and now they fit in place. I copied them, it seems, instead of moving them. But no worries, I can delete them. Okay, so I just showed you this much faster than last time. Of course, this wall here is missing, so I have to draw it very quickly. I'll just go here and say wall. So let me show you very quickly what happens if you run the analysis. Let's calculate. Of course, the structure is totally unstable. Separate, continue. Okay, just ignore this instability. I need to stabilize it later. See, column is out. It's not in the place. Okay. It seems my column is not in place. That's odd. I have to modify it then. Why is it not in place? I moved it, right? Did I move it too much? I think I moved it too much. So I'll take this. So edit, move or copy, and I move the column to the inside. So move from here to the perpendicular distance. Well, yes. Let's go to top again. Yes, it was perpendicular. And now I will take the same column here. This one that's outside. I close this, select, and shift like this. Edit. I lost the selection. Let me select again. There we go. Move a little bit. Now edit, move or copy. I'm gonna move it, and I'm gonna move it from the position here to a perpendicular. I need to find the perpendicular to the wall. There we go. Okay. Now the columns are connected to the wall. If I mesh, I should see a mesh at that point. So let's take a look. And indeed, I see nodes. The wall has been meshed fantastically correctly. Now the columns are part of the walls. We continue. There are some columns here that I need to move. Let's check. There was a column here. It got deleted, it seems. Did it get deleted? No, it was moved, right? Those are all moved. That's fantastic. This is moved. There's no column here. Okay, it seems we are done. It seems we have moved our columns correctly. I did this off screen, I guess. At least we addressed the issue of connecting columns with the walls. Now let's go to beams. So let me just first of all delete everything. And I will here very quickly define me some beams. Beam section 300 by 500, because I want to have the beam section similar to the column section. Inertia has been reduced. Has it been reduced? Let me just check. Sections. Inertia has been reduced. I will click here. Yes, it has been reduced as per the beam recommendation. I will delete one of those things because I want to see. It's strange I cannot turn it off. That's really odd. So what I can do is I can just throw it up. I delete one, so I can click here and say delete button. And this I will keep just in case, but I will throw it somewhere else. So I'll just go here, click somewhere here, and put it at z equals 100 because I don't want to see it. I need to focus on my work. Let's continue here. I want to make me some beams, so I need some structural axis for the beams, or I can play a trick very quickly and add me a beam, RC beam. Now here I don't think I need a beam, but here I need beams. So this is my beam. That's one of them. And I just draw me some beams. I have a nice trick up my sleeve. I don't know if Robot will cooperate. Let me show you. If I go to edit, there's something called extend or something. There we go, extend. It wants the boundary edge. This is the boundary edge. Does it select? I think it does. And then it wants me to extend. So There we go. Fine. So that's my plan. I will draw my beams and then extend. So let's draw the beams, making sure I'm clicking the correct points because I will extend them. So I'm just clicking and clicking and clicking. Yeah, now there's the ramp. Let me just show you. The ramp I need to figure out later. I make me a beam here, but this ramp needs to be planned accordingly. Okay, so let's go to the extend. So I'll go to edit, extend, and I will select this and this as my boundary object. And okay, I'll click here once for this, once left, once right, and you see, it's just a simple thing of extending. Robot is amazing with its modeling techniques and modeling systems. Yeah, there we go. So I have extended that. Now my beams are extended, but I still want some perpendicular beams, tie beams I would call them. Let me make another section just to ease my selection process. So I'll make me a 300 by 400 section, rectangular, because I want to be able to select via section in the future, so I'm planning ahead. And add and close. Those might be secondary beams or tie beams, so I will just draw me one. I just click, drag, and start clicking on those columns. So here, I don't think I will extend the last one, because here there's a ramp. Extending a beam beyond the ramp just doesn't make sense. It would be inside the ramp, which would not be feasible. It doesn't make sense. So the last one cannot be extended. I have to think about it. Those columns seem to be almost aligned with the shear wall. I don't know, should I make them aligned or should I keep them separate? I keep them separate for now. I need to think about this. See, so many questions come into mind when you model, and I'm trying to capture all the questions by thinking aloud. It's totally okay to be a little bit thinking. It's totally okay to be a little bit undecided and think about the best way of approaching this dilemma in the future. So for now, I just fixed my, so the way I model usually is I model the things I'm 100% sure of, and then start researching things I need to take decisions about. So I here go quickly to edit, extend. No, I don't need to extend. I have my columns. I could just connect with the columns, right? So I can just click from here to here. Let me just make sure I'm clicking the correct node. So that's that. And now again, from this here to this, let me just click correctly. There we go. Let me just first of all flip a little bit and see if it's looking good. Front, yeah, I think it's looking good. Let me just mesh. Okay, it seems everything is fine. Now I need to put a slab, and still, so far I haven't done anything with loads. I had requests talk about live load redistribution and reduction, and I have it in my mind, I have it on my radar. Also, there were requests asking me to make a raft foundation. This project will take some time for accomplishment because I'm doing it on a weekly basis. I will just continue with the floor, and it's a shell. One thing you could think about is just to, to slab the entire building. That's okay. But if you slab the entire building, robot will suffer in meshing. So what I like to do is I like to compartmentalize, if that's a good word, to compartmentalize my meshing base. It helps robot easily identify. Wait, what? There is an odd thing here. What is this? I messed up the position of my wall. And now it's time to slab that thing. So I just go here. I will select me a different thickness because I want to be able to select them based on the... Is there a way to select based on thickness? There isn't. Okay, then I just keep the thickness as is. Now I will try to compartmentalize my slab to make it easier for the mesher to mesh it. So I'm just being a little bit more considerate of how I am drawing my slab. There is a problem here. Okay, let's take a look if it worked now. Yes, now it's working on all edges, so now I have to take this and move it again. or to this, I guess. Okay, so save, and let's run again. Let's run the mesh up. Let's see if it meshes. Okay, it sees this column, it sees, okay, we have fixed the problem, it seems. So we continue now our efforts in putting a slab on this. So I delete the mesh, I select the slab, and I start slabbing. Of course, I'm using the same slab here, so I'm being very careful to define my first line horizontal to the x-axis, because I want the local x-axis of the slab to be the same as the global x-axis of the structure. Of course, if you want more details, I had a little principles in Slab that I will link above. Also, I have a full Slab series that I will link above. So check out that if you want more details about how to draw those slabs. Let's run the measure to see if there are any conglomerations of points that needs attention. Okay, so far it seems good, so let's delete the mesh. Here, I'm gonna click some extra clicks just to make sure that I am clicking on the edges of those walls. Okay, reach those elevators. Notice that there are no slabs on the elevator because those are actually empty places. Those are empty. The slab is here. And there is even a staircase, so the slab is only partially, and the rest is not a slab. So I'll slab that. Let me run the mesher, speaking of which. Let's see if it still is able to mesh. Okay, it's meshing those, it was just a small hiccup. So no, don't continue. Cancel, overlapped. Okay, we have a problem. We have overlapped panels, and the question is where it is, right? Show me. Where are those overlapped panels? It doesn't show, there we go. Are you sure about that? I don't see any overlap panels here. Okay, that's a warning I don't like to see. This is here, this ends here, and this starts here. There's no overlap, okay? And here, this ends here, and this ends here. So where are the overlap panels? I think I see something. Do I see something? I think I see something. Yeah, I think this is extending a little bit beyond what it's supposed to be. Is it the same here? Yes, there are some problems. Okay. Can I fix that easily? Let me just delete the mesh. Okay, it's deleted now. Okay, so the problem was with this one, it seems to be overlapping. Is it? Wait, I have two panels here. Wait. I think I know what happened. Okay, which one is good, which one is bad? Let's take a look. Let me click on that. Yeah, this seems to be okay. This seems to be out of place. Let me delete that. Now let's run the mesh again, hoping that no doomsday scenario happen. Okay, see, now the mesh is much more user-friendly. Okay. And that's a staircase. I cannot touch that, right? This place I cannot touch. This work is where the money is. Because once the model is there, things just become a software perspective. Of course, you need to know what you're doing in the software, but the software does it for you. It's exactly those errors that you have to understand and tackle and deal with. And that's basically where the money is. Okay, so yet again, some progress has been made in the basement. So I'll just check this very quickly, if it's meshing correctly or not. It did mesh correctly, I don't see any nuances, so now I can just take this and I can basically copy the story, right? So if I go to, or I can just select and say edit, move or copy. Okay, first of all, let me delete the mesh, because I don't want to copy the mesh nodes. So here, delete the mesh, there we go. Okay, now I'll select those things, exception down, and edit, move or copy, and I'm going to move it 003.5 in the Z. Execute, and now I have two stories of the basement. Great. That's a good thing to start with. Did I have everything? I think I did. So now, I'll just run a quick check on the mesh. Of course, the structure is now suffering, but the mesh seems to be okay-ish. I don't see a problem so far, so I think that's a good job. So, yeah. With that, I think we have finished modeling the basement, with exception. Oh wait, I thought I didn't copy those supports. But that's easy. I'll just go here very quickly, select those all, basically, go to support, add a delete to the nodes, and add a delete to those things. Can I do that? Let me just try. It doesn't work. Really? I have to do it by hand? Okay, let me delete the mesh first of all. Okay. Do I have... It seems I have some supports. Remove the section. No supports. Okay, I have supports for walls. This is incorrect. So I go to support, click delete, and basically start deleting those supports. Okay, so I think now we are correct, I guess. Okay, so from what I'm gathering right now, I just want to generate the mesh. Yep. I think the modeling of the basement is complete with exception to the staircase and the car ramp. This will come in later stages, but the basement itself has been accomplished. So I think we did a great job, and I think I can end this video here with this thing being achieved. So with that being said, I hope that you enjoyed the video, and before I finish, I want to give a tower basement sized shout out to our dear channel members in the contributor level, whose names are going to be shown on the screen, as well as the helper level, whose names are also going to be shown on the screen. I want to thank them from the bottom of my heart, as the support to the channel is priceless to me and enables me to keep pushing those videos on time, hopefully, and with a certain level of explanation that I always intend to have. With that being said, I hope that you enjoyed the video and that was beneficial for you. Of course, if you have enjoyed the video, then please consider sacrificing to the YouTube algorithm by liking, sharing, commenting, and subscribing to the channel, especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.